Thank you. Good morning. My name is Lynn and I work at Spotify. I am a staff engineer. It's based in New York, and I've been at Spotify for just over like 8.5 years now. And I'm sorry, I think this part of the room won't really see me. I'm kind of short. So I've been building infrastructure at Spotify for maybe about 5 years and concentrating on audio processing and like ML-based audio stuff. You also might know me from PyLadies. I'm the chair of the Global Council for PyLadies. And it's been a few years, and I've completely forgotten how to write a talk, particularly a concise talk. So I'm going to be taking up the whole like half hour, not necessarily having time for Q&A, but I'm happy to answer questions afterwards at lunch or maybe across the street at the River Bar. So I'm just going to jump right into it. About 10 years ago, I bought an electric kettle from Breville, and it had this plug. And this plug essentially blew my mind. I know it's an American plug, bear with me. But basically, I thought, why don't all plugs have this like nice hole in it? Not only does it make it really easy to unplug, you don't have to like fiddle or electrocute yourself, but it's also very obvious to me how to use it. It allows for like easy grabbing and pulling. And so the simplicity, the thoughtfulness of the design made me think, what else am I unknowingly struggling with? So this brought me to this book called The Design of Everyday Things by Don Norman, which you might notice is kind of the title of my talk, but with APIs. It's got this nice little coffee pot. It's dubbed the masochistic coffee pot. And the premise of this book is basically how design serves as a communication between the object and the user, and how to optimize that communication. And so Don Norman writes, design is concerned with how things work, how they are controlled, and the nature of the interaction between people and technology. And so the range of things is not limited to physical objects, like the Breville plug that I'm in love with, or the masochistic teapot or coffee pot. It also includes like artificial creations like software and digital interfaces, the layout of conference rooms, organizational structures, et cetera. And so what exactly makes design good? So Don Norman says, two of the most important characteristics of good design is discoverability and understanding. And so if we break down this a little bit further, discoverability is described as, am I able to figure out what actions are possible and where and how to perform them? So this author lays out 5 key elements of discoverability. And I'm sorry, for the sake of time, I'm going to breeze through them. The first one is affordances. Affordances determine what actions are possible. It's what a user can do with the object based on their capabilities. Building off of affordances is the second one, signifiers. A signifier is some sort of perceivable cue about the affordance. The third one is constraints. And basically, constraints are limitations or restrictions, and they give us clues that allow us to determine a course of action by limiting the actions available to us. The fourth element is mappings. A mapping is the relationship between a control and an action. And an example of a good mapping is maybe you have 2 lights and then 2 light switches, and then the left light switch controls the left light and vice versa. And then the final key element is feedback, where the results of an action is communicated back to the user. And of course, immediate feedback is ideal, and delayed feedback can be disconcerting and lead to a feeling of user abandonment. So these key elements of discoverability help build up the second part of good design, of understanding. And so understandability means, is it possible or easy for users to figure out how a product can be used? Understanding is developed by forming a conceptual or mental model of how things work. Conceptual model is just a collection of explanations, often just like simplified. And so the user has their own conceptual model of how a system or how a product works. And then the designer designs their system or product using their own conceptual model. Designers often expect the user's conceptual model to be identical to their own, but because they cannot communicate directly with the user, the burden of communication is on the system and its design. And so good conceptual models are the key to understandable, enjoyable products, and good communication is the key to good conceptual models. And then we build up that that communication with this discovery, with affordances, signifiers, mapping, constraints, and feedback. And so you might be able to start to see how these ideas, essentially like human-centered design, and how we can kind of apply that to software, to designing a library for other people to use. So my first instinct was about looking at how libraries I've worked with, and maybe some that are not fun to use, maybe some I've even developed that are not fun to use. And I don't really want to name and shame any Python libraries here, but one non-Python library that maybe you're familiar with that I particularly loathe is ffmpeg. You're not supposed to be able to read this, but it's a well-known CLI tool that is designed for processing audio and video. This screen recording is just me listing documentation for some command. And so whenever I use ffmpeg, it's a way for me to figure out how to do something seemingly simple, like creating a looping GIF based off of video. But then I often need to go to Stack Overflow to copy commands because I'm sorry, this documentation sucks. And it's so powerful, I know it can do a lot of things that I can't even fathom. And I'll probably continue to reach for it because there's nothing better out there, and it's quite performant. But there will always be this sort of kind of reaction when I need to use it. And so this made me think, if I'm an engineer who develops tools and infrastructure for fellow engineers, how many masochistic teapots have I unknowingly shipped? And how many sighs have I caused? And so there are much, much better people to give talks on API design, about the theory, so I'm not an authority of this. But for me, there's a missing connection between the theory of good API design and the actual implementation. So this brings me to why I'm here today. I'm not sure if folks have seen previous talks or read blog posts of mine, but I have a habit of writing talks for myself, ones that I really wish I've seen years ago. So this talk is mainly for past Lynn, a talk that tries to take the key elements of good API design and apply them to a real-world-ish example. So I was able to condense this into 3 tenets, the 3 key principles that make a delightful to work with API. So first I want to set the stage. Let's say that we are going to design a library to work with a pub sub queue-like service. And I'm just going to call it a chaos queue, because why not? It has nothing to do with this car, I just like it, it's really cool. But let's start with some starting code. So first, we have a message object, and it contains the data that's going to be passed to and from a chaos queue. And then we have a second class, a client that essentially publishes to and consumes from our chaos pub sub queue. And this is our starting library. And perhaps you're already thinking about how to improve it, which is good, but just hold tight. And so in order to develop some user empathy, I want to also write a bit of user code that interacts with my library. So on the user side, we create a chaos pub sub queue client, create a topic and subscription, catching it if it already exists, continuing on. And then we start interacting with our client. We first have a for loop publishing 5 messages to our chaos queue, and then a while true loop to consume those messages. We print the message, maybe that's a leftover from debugging, and then go on to do some sort of processing of the message data. When we're done, we acknowledge the message from the queue. And then finally, maybe the client has some network connections that we need to close and clean up, maybe buffers some need to flush, so we need to close the client. And so let's improve this for the user and start iterating on our library. So I'll start with my first of 3 principles. And API should be intuitive. And note, I mean intuitive for the user and not for you, the implementer. So with an intuitive API, a user can be lazy. They don't have to think too hard about how it works. They won't have to remember complicated details because their intuition correctly explains it to them. They don't have to spend a lot of time learning new parts of the API because it all works pretty similarly. So an intuitive API builds on users' pre-existing conceptual models and tries not to do anything surprising, tries not to unnecessarily work against logical constraints. And with that, I have 3 changes that I want to make to our API. So we're going to start with some low-hanging fruit and name the methods in our client class using the domains nomenclature, like publish a message to a queue or pull a message from a queue, acknowledging a message that we're done, and draining a queue of messages. So right now, we have add message, get message, mark message done, and clear message queue. And then let's just go ahead and rename them to publish, pull, ack, and drain. I've also dropped the noun from the method names since I found them a little redundant, because in my mind, the noun that we're operating on is actually in the function signature. And now I have room on my slide to indent 4 spaces instead of 2. And so why are we doing this? This sort of plays into the mappings element of discoverability. Naming your functions something familiar to the domain that we're supposed to work in can help result in immediate understanding of how to use your API and what it's supposed to do. The next suggested change kind of steps back a tiny bit and to think about appropriate abstraction levels. Clumsy naming hints at clumsy abstractions, and even the slide itself is a little bit clumsy. But if you recall, we have a pub subclient, and we have a few curious methods: create topic, create subscription, and close client. But this client seems to manage a lot in one object. From the user's point of view, what if we're just trying to consume messages, not publish them? Do I have to create a topic for some reason? Will there be multiple connections managed by this client and some unnecessary? So then let's not add any unnecessary confusion. Confusion isn't necessary to begin with. And break this up into 2. So one that works with publishing and then one that works with subscribing. This also allows us to clean up the method names a little bit and then creates natural constraints on what the user can do. They have to instantiate a pub client if they want to create a topic. However, our clients are still creating some unnecessary constraints on our users, which brings me to my third change. Let's make sure that our API has symmetry. So we allow the user to create a topic or create a subscription, but what if they want to update or change a subscription or want to delete a topic? So let's not limit the user unnecessarily and provide symmetry with our methods. Just having that create method without its logical pair or triplet gives sort of a misleading signifier to the user. We can be certain that users have worked with other APIs that provide symmetric methods like create and delete, or get and set, or upload and download. It would be kind of counterintuitive to not provide that functionality, or provide that functionality and not follow the convention in symmetrical naming. So some of these changes, they might be a bit contrived. It's kind of hard to come up with a simple, succinct example that's also relatable, but hopefully that the message comes through. And some changes later on in the talk could very well apply to this intuitive tenet. And I'm sure there are changes that I'm not even addressing or thinking of. But let's move on to the next one. An API should be flexible. And again, I mean flexible for the user. It's a whole nother talk to create flexible APIs for maintainers and contributors. So basically, a flexible API lets you do what you want. From my point of view, a flexible API lets the user to get started quickly with more basic use cases, and then allows the user to adjust and learn as they need to solve more complex problems. Basically, flexibility comes down to how many problems can the user solve once they learn that API. And so for this tenet, I have 4 changes I want to make to our chaos queue library. The first one is providing sane defaults to the most common use cases. So we recall that we have some methods that work with publishing and consuming messages. The main resource these methods are working with are messages. The timeout and retry arguments are not required to the core functionality of publishing, polling, or acknowledging. Also, I found myself as a user to not know what a good number of seconds the default should be or how many retries it should be making. And so as an API designer, I should make optional behavior as optional keyword arguments. Maybe 30 seconds is the most common timeout value. Maybe it comes from the server itself. Maybe it's also default to just do 0 retries. And this change goes beyond the flexibility of the API, forcing the use of keyword arguments and providing sane defaults. We limit the number and the order of positional arguments that the user has to remember. So for instance, both timeout and retries are integers. So if they were positional arguments like before, the user could easily inverse that, and type checkers would not catch that. So maybe we have many more optional keyword arguments like request ID or verbosity, maybe many, many more. And we could roll these all up into keyword arguments into star kwargs. And then we could take care of the kwarg parsing for them. And so by removing a lot of the optional settings from the method signature, this kind of allows the user to just focus on what they need to learn first. You might argue that this removes the ability to add type hints, which then can provide user documentation and IDE support, and that's certainly a valid argument. I would agree with that. With both cases, though, both keyword args and star kwargs, if you have too many arguments, you might want to kind of step back, because that might be another hint at clumsy code, and you might be unnecessarily exposing complexity. So with type hints and with a lot of arguments, if folks can't really understand your annotations, then you might want to rethink and kind of refactor this code. But one thing about star kwargs is you can change your parameters in the future, and those will not be breaking. It also allows me to have a cleaner slide. The second change I want to make to increase flexibility for our APIs to minimize the user's need to repeat themselves. We saw a loop in users' code to publish all of the 5 messages. And so in our pub client, our publish message has only one positional argument for message. To minimize forcing the user to repeatedly call publish for each message, we can accept multiple messages in the function signature by collecting them into star args. And then we could do the repetitive work for them. So hopefully, you're writing user code as you're building your API. And so while doing so, you can then look for kind of common patterns in users' code that you can try and minimize away, like loops and repetition. As I said earlier, the tenet of flexibility is meant for the user's point of view. Providing flexibility to the user requires you to be predictable and to be precise. So if you recall, part of that building conceptual model, that understanding for the user is to provide constraints and feedback. We want to provide flexibility with what we accept as input, but then we need to have a clear constraint in what we return. We shouldn't make the user figure out what object type they got back from a method of ours. So if you recall our subscription client that returns a consumed message or none. So this doesn't seem too precise or predictable in my point of view. So the user essentially has to check if they got a message at all or if they're dealing with none. So what is the none use case here? It's when there are no more messages in the queue to consume. If we take a look at pre-existing APIs, like the Python built-in queue library, it raises an error when the queue is empty, and so that seems pretty reasonable. So we can update our function signature to only return a message object, and then raise if there are no messages in the subscription queue. And this goes back to what Don Norman says about feedback, that it should be that we should communicate clear, unambiguous information back to the user in order for them to be effective. This last change I want to make, again, supports the users being lazy. Let's not force the users to provide data that we can generate ourselves. So we have this message object. It has ID, some data, and a published timestamp. And now when creating a message, there's no need for users to provide their own unique ID. We should probably actually be taking care of that for them, or to timestamp it when it's published. So we can do that ourselves. We probably wouldn't have the timestamp actually on instantiation of a message, probably on published, just bear with me. So hopefully we also, let me go back. We've basically updated this to make them only provide the data and generate the ID if they haven't provided, or publish timestamp if they haven't provided. And then hopefully, we have some user understanding. We understand that users debug and print or log a message for debugging purposes. And for that, we should provide a repr method so that they won't have to worry about printing necessary attributes, but just the message itself. So this is just one approach to redefining our object to help out the user. We could also use data classes. This removes some boilerplate for us. It does get a little clumsy with setting defaults. It kind of goes off to the slide, but it's still nice. The third option would be to use third-party package adders, which allows me to go back to a four-space indentation. But also, if I needed, adders would give me more to provide flexibility, constraints for users, since not only does it give me a clean way to set dynamic defaults, but it also can give me validation, converters, and maybe the ability to abuse init if I wanted to. I'm not a paid shill for adders, I'm just a happy user. So if your API is not flexible, you'll find yourself saying, I'm sorry, I know our API should do that, but for reasons that you don't care and that's in our control, we can't. So if an API is not flexible, users eventually ditch the API and go somewhere else to solve their problems. And now the last tenet, an API should be simple. The complexity of an API can be measured by the cognitive load it requires to actually use it. Complexity hurts our understanding. And we've already made some changes to reduce the cognitive load of our API, like consistent and appropriate method naming, limiting the number of positional arguments in our function signatures, minimizing the amount of repetition, but we can make a few more changes to make it more simple. So the first change is to provide composable functions. APIs that follow the mathematical closure property tend to be a bit more simple as well as flexible. And so loosely, an API holds that closure property when every operation returns a data type that can then be fed into another operation. So this means that different operations of your API can be composed with each other. So for example, like in Python, we're able to chain a bunch of string methods together since the output of many string methods is yet another string. The closure property makes it easy to combine multiple operations for the desired result. Maybe users don't need this, don't use this, but it does allow users to not have to remember the different function signatures when operating on essentially the same object. So looking at our subscription client, we have two methods that operate on a message object. And it's pretty reasonable to think that once you pull a message from the chaos queue, you want to acknowledge it when you're done. Otherwise, it'll get redelivered and doing unnecessary duplicate work. So there's no reason for us to be restrictive in our function signature for acking and requiring a string. This adds cognitive load to the user. They have to remember that they must give an ID of the message that they want to ack, and they can't pass in the object that they've been working with. So let's change this to just take in the message object itself. It's pretty easy for us to get the ID from there. So now it's simpler for the user to just pull a message from the subscription and then ack it once they're done. Now while we're at it, we can also accept the ability for the users to give us multiple messages if they want to batch up their acknowledgements for whatever reason. And it certainly adds kind of symmetry to our method signatures. The next one I want to talk about is basically align the API with Python idioms, making it more Pythonic. Leveraging language idioms also leans into what a programming language affords. Different programming languages allow you to, or afford you, different approach to kinds of problems that we solve. Like supporting reflection and introspection, or supporting the ability to have default values, or how to define an iterator. So if you look again at our subscription client, the user has to call pull to get a single message. And as you might recall from earlier, that user code has like a while true loop to pull every message. And so let's make it easier for the user and provide an iter method that returns an iterable. Providing an iterator is helpful for cases like this, especially where users are consuming a stream of events or a stream of data. It's also helpful when users might need to page through results like a search query with hundreds or thousands of items. So this iter method also happens to simplify the user code even more. The iterable just stops when there's no more messages. The user now is able to remove a try and except for the empty queue when they're with their consuming code. And then continuing on leveraging the language idioms, you might remember that both clients have a close method, managing many connections and maybe some buffers underneath the hood. So this forces the user to clean up after themselves, adding complexity and cognitive load. You might see where this is going. So let's make use of a context manager here, providing an easy way for users to not have to worry about remembering any finalization or cleanup behavior. And then for our last change, it's not really a change of our code, but we can also think about simplicity as convenient to get started. How much do I have to learn to be able to use this library? And what do I have to do right now to get this working? So if an API is not convenient, if like I have to take many steps to get started, if I have to page through a lot of documentation just for a simple understanding, the tool's adoption will suffer. So provide your user with convenience, and you can do this by treating your README as you would like a newspaper. Give them the most important details first, like above the fold. And if users want to learn more, they can just like turn the page. So when I'm looking at a README, I want 3 things above the fold. How do I get your library? Do I need any system level or non-Python dependencies? And then what are like 1 or 2 examples that I can literally just copy and paste to try it out? And as a side note, reconsider your examples if they're needed. If you use the REPL, I consider it really annoying to copy and paste code and then have to delete all like the REPL part. Maybe that's just a pet peeve of mine. And then 3, where do I go for more information? So basically, give me those 3 things at the top of your README, and I'm good to go to get started with your API. And so creating a simple API, it's all about reducing cognitive load on the user, reducing what the user has to keep in their head while working with their API, your API. Okay, that was a lot. Let's review. So we started here, very simple API, only containing 2 classes. And as we went on, we broke our code into 3 classes, so this is intentionally unreadable, but that's okay. Because we started with a lot of user code, 29 lines to be exact here, and we got down to just 14 lines where we can fit all the code in one slide and be kind of readable. So this should be the goal, not necessarily the number of lines of user code, but it's about user empathy when designing a delightful API. Okay, so to recap, is your API intuitive? Is it flexible for the user's use cases? Is it simple enough to essentially just learn once? So you have to keep in mind your software will become a part of a larger system. Your only choice is whether it is a well-behaved part of a larger system. But the how, I know, can be a bit elusive, and so hopefully this progressive example of improving my dummy API is a bit helpful. And it's a lot to remember, I know. So if you only remember like one thing from this talk, besides my like cheeky, awesome synthwave theme that I created, then remember this. If all else fails, standardize. Don Norman leaves us with kind of a good catch-all here. When no other solution appears possible, then design everything the same way so people only have to learn once. Okay, so that was my talk. You can find my slides with some additional resources and credits and stuff like that at this link. And I won't take any questions now, but I'll happily stay behind and talk to you later or right after. So thank you.